All right, so section 2.5, that's what we're going to start with. Whatever time we have left, we're going to look at part of 3.1. Whatever we don't finish, we'll finish that tomorrow. We're going to look at solving inequalities that have exponents higher than a 1. Okay, like quadratic or cubic, things like that. And one formula that we used before when we were solving equations that had exponents higher than 1 was this formula for projectile motion. Okay, that's a quadratic. And the formula is the negative 16t squared plus v sub 0 t plus s sub 0. V sub 0 is an initial velocity. S sub 0 is an initial height. And t is time in seconds. Now, when we did this before, we looked at solving a problem where we found when it was exactly at a certain height. Well, now we're going to replace this with an inequality. Instead of finding when it's exactly a height, we'll find when it's above a certain height. And the first one we're going to do on the calculator. The second one we'll do, I'll show you how to do it with algebra. We're gonna start with the calculator. Okay, and in our problem, we're throwing an object from ground level with an initial speed of 80 feet per second. So first thing we have to do before we can even use the calculator is we need to come up with something to plug in. So the formula has a couple variables you need to know: initial velocity and initial height. What's my initial velocity? Yeah? 80. What's my initial height? 0. So if you fill in those two values into the formula up above, can you tell me what the right-hand side would look like? It's not going to be anything you have to calculate. It's just going to be a substitution at this point for what's on the right-hand side with the information that's in the problem. Because I haven't told you anything else, so you can't solve it yet. Negative 16t squared, and what was the other thing? Plus 80t. Yeah. That's it. Negative 16t squared plus 80t. So now I'm going to give you a piece of information that allows you to solve it. I want to know when the height is at least 64 feet. What is that? At least 64 feet. Turn that into like an inequality symbol for me. Dylan?
Greater than or equal to.
Greater than or equal to. Yep. All right, well, let's graph it. So we've got, might already have it. No, I don't. So negative 16t squared plus 80t. Let's just graph that first. Okay. So this is going to represent the height of the ball after a certain amount of time. X is time. Remember, you can't use t on the calculator. You have to use x. So what's the smallest value that the time could be? Yeah.
0.
Right. You can't go before we launch the object. 0 is the beginning. The maximum amount of time, we don't know. That's how long it's in the air for. So if it goes off the screen, we'll adjust that later. Y is the height. What's the minimum height that this object would have? Yeah, 0. You can't, it's not going below ground. It's just 0 is the lowest height. Now the maximum height, well, when we throw it, it's being thrown at 80 feet per second. Now the second it leaves your hand, it's going to slow down because gravity is going to start slowing it down right away. So I would maybe just try like a maximum height of maybe like a little over 100 feet. Try that and see. So let's try like maybe 110. It doesn't really matter what value you use, as long as you can see the top. Yeah, that's good. Okay, so now we've got a parabola like that. And we want to know when it's above or equal to 64. So what could I add on the screen to mark where 64 would be? Yeah?
Or y value at 64.
Yeah, just put a y value at 64, and that'll give you a horizontal line. And now the question is, when is it above that line? Above or equal? Above or equal. So what do you think I need to find out from that picture? I'm going to use the calculator, Bridget.
That intersection.
I need both intersection points. Okay, I just remember from the last class, they are nice numbers. I'll do the one on the left just to remind you how to do it. Second calc intersect. Remember, you put your cursor closer to the one you want, and then hit enter 3 times. So the first intersection point is at 1. I'll just mark this. And you can double check me, but I think the second one is 4. So there's your first one, 164. And the second one is 464. So now, are we interested in the part of the parabola that's above the line, or the 2 parts that are below? Above. So what is the time frame when we are above 64 feet? Yeah.
Equal, greater than or equal to 1 second and less, or less than or equal to 4 seconds.
Yeah, when the time is greater than or equal to 1 second and less than or equal to 4 seconds. That's when you are above 64 feet. Above or equal. Any question on that one? Okay. So now, the next question is, how long is the ball in the air? This time I'm going to use algebra to solve it. I'm not going to graph it. Okay, let's use it. Well, if the ball is in the air, what does that mean about it? Yeah?
Its height is greater than 0.
The height is greater than 0. Okay, it's not on the ground. So the height is greater than 0. Now fill in your formula for the height. It's negative 16t squared plus 80t is greater than 0. Now the way we're going to solve this is pretty much the way we're going to solve every inequality that has exponent of 2 or higher. We can't really use quadratic formula with inequalities. That won't quite work. What's another method for solving a quadratic? You probably learned this one before you learn quadratic formula. But it only works if the numbers are nice. Yeah? Right, we're going to factor. And in this case, it's just a GCF. So we're going to factor out whatever we can on the left-hand side and then see what we have left. What can you factor out of negative 16t squared plus 80t? What's the GCF there? Yeah?
8.
You can factor out 8. 8 is a common factor, but it's not the greatest common factor. Yeah?
18.
That's a little bit better. That's another common factor, but it's still not the biggest one. Anyone else have a guess? Ethan?
This is 16.
Yeah, it's 16t. And if you want to do the negative with it, we can do it negative too. That part doesn't matter as much. But yeah, we're going to factor out a negative 16t. What would that leave me with inside the parentheses if I factor out negative 16t? Yeah?
X plus 5.
A couple things. First, we're going to make sure we use t. But not quite. I like the first letter was right. Okay, that's just a letter. But what's the number going to be? It's not a plus 5. Yeah?
Minus 5.
Yeah, it'd have to be a minus 5. Because we factored out the negative. Alright, now we want to use a little bit of common sense and think about this. You've got something times something, and it has to be bigger than 0. Well, let's start with this. T is always going to be what kind of number? T is always going to be a positive. Negative 16 is always a negative. So inside the parentheses here, it's always going to be a positive times a negative, which is a what?
Negative.
A negative. So no matter what you do, the first number here is going to be a negative. Now, when you multiply this negative number times this, it has to come out positive. What kind of number does that mean the second parentheses have to be? If the whole thing is going to come out bigger than 0. Yeah? This has to be a negative. And that is the whole question then. When is t minus 5 a negative number? If we can answer that, that tells us how long the ball is in the air for. So when is t minus 5 a negative number? Because if t minus 5 comes out positive, then you're going to have a negative times a positive. That's not going to be bigger than 0. That doesn't answer the question. Okay? It has to come out negative to answer this question. Okay, so when is t minus 5 negative? You get that. And what do you get when you solve for t? Yep.
When t is less than 5.
When t is less than 5. So that tells you basically the ball is in the air for how long? Joy? Well, what does it say for our final answer? So t is less than 5, yeah. So how long is the ball in the air for? Am I sure? Anyone help her out? How long is it in the air for? Yeah. Less than 5 seconds. The time is less than 5 seconds. So what does that really mean? Well, I guess it means like 4.9 repeated. So at 5 seconds, it's on the ground. It's in the air less than 5 seconds. Any question on that? So we're going to look at doing more of what we just did right here. Factoring something, so we get two factors, and then figuring out like whether it's a negative, whether it's a positive, what it has to be. And that's called the sign pattern. Okay? The sign is either a positive or a negative. So this whole process relies on you being able to factor. If you can't factor the question I give you, then this whole method doesn't work. Okay? It has to be a problem that's factorable. So let's say you had something like this. You factored something out. That was one of the factors, x minus 3. What number could you plug in for x there? And you'd get 0. Yeah? 3. So what we do on a number line is we mark the number that would give us 0. Then we're going to look at each section. There's a section below 3 and there's a section above 3. Let's look at the section below 3. If you pick a number that's below 3 and you fill it in for x, what kind of answer will you get? A positive or will you get a negative?
Negative.
You're going to get a negative. So this part of the number line would give you negative answers if you fill it in for x. What about if you pick a number that's bigger than 3 and you fill it in for x? Yeah. You get a positive. That is called a sign pattern. You mark the number that gives you 0, and then you label each section of the number line as negative or positive. And you might think, well, it's just going to always be negative on the left, positive on the right. A lot of times it will be, unless I do this. Now everything just flipped. All right? And it messes up the 0 as well. So now the 0 would be negative 3. And then the negative positive would flip. But a lot of times when we factor, there isn't a negative in front of the x. Okay, it's usually like that. Okay, so that's a linear factor, x minus 3. Here's a couple more linear factors. T plus 4, t minus 1. Okay, linear just means it's a letter plus or minus a number. Nothing squared, nothing cubed. It's just like how you would factor a quadratic. And every linear factor has exactly one number that makes it 0. Like here you could plug in 1 and you get 0. Here you could plug in -4 and you get 0. In the one I made up, you could plug in 3. So that's the first step. You have to be able to take your problem and factor it. And then the second step is to draw that number line that I did in the upper right. So you make a number line. You mark the number that would give you 0. And when you do that, you're going to break the number line into 2 sections. You're going to have a section to the left and then another section to the right. You have to determine the sign in each section of the number line. And by sign, you have 2 choices, negative, positive. Okay, instead of writing like the word negative and the word positive each time, I'm probably just going to use these symbols to represent negative and positive. Now there's one more step. So I would say leave, the next step we have to write is probably about that long. So I'd leave about that much space for one more step. But I want to try it. I want to try a problem up to that step. Okay, so we'll do a problem, and then when we get to this point where we're done here, I'll give you the last step, and then we'll do that. And again, this method only works if you can factor. You can't factor, you can't do this. It won't work. Okay, so that's what I'm going to come back to and tell you after. Let's try this one. So it says 2x squared plus 9x minus 5 is greater than 0. Okay, if you're going to factor something, what do you always have to get it equal to first? 0. No different here. Okay. If it wasn't equal to 0, I would make it equal to 0 first. Okay, now it's ready to factor. What 2 things would I multiply together that would give me 2x squared? Yeah?
2x and x.
I'm going to need a 2x and x. I've got a positive 9 and a negative 5. What does that mean about the signs that I put when I factor it? Yep.
One's a plus, one's a minus.
One's a plus, one's a minus. I would do it like this. You can try it a different way if you want. Good luck. It's not going to work. So let's do it that way. And now 2 numbers that multiply to give me 5. Well, 5 is prime. So what 2 numbers multiply to give you 5? 5 and 1, and I would do it in this order. That gives you 10x minus 1x, which is 9x. All right, so we factored it. That's the first thing. Now, we're going to make a number line for this factor and that factor. And we're going to mark the number that would give you 0 for both of them. Okay, so let's start with 2x minus 1. It doesn't matter where you put the mark. The mark is put in the middle if you want. What number would you plug into 2x minus 1? That would give you 0. Okay. What number would you plug in? So we're looking for a number you would plug in for x that would give you 0 when you do it out. In the top. So it won't be a negative. It will be a positive number. 1? No, if you plug in 1, yeah, you get 2 minus 1, which gives you 1. 3? Well, if you plug in 3, 2 times 3 is going to give you 6 minus 1 is 5. So it's going to have to be a fraction, Bruce.
1/2.
1/2, yeah. If you plug in 1/2, half of 2 is 1 minus 1 is 0. So we're marking the 0 there. Let's mark 0 on the other one. Put the mark anywhere you want. Doesn't really matter. It's not relative to the first one. X plus 5. Right. What would we plug in there to get 0? Yep.
-5.
-5. Now we've got 2 sections on each number line to look at. Some will result in negatives, some will be positives. Let's check it out. Okay. In the top number line, pick a number less than 1/2. Right? 0. Whatever number you want. If you fill in a number that's less than 1/2 right there, what kind of answer will you get? A negative or a positive? Yep. Get a negative. What if you plug in an answer bigger than 1/2 for x? Plug in 3. What kind of answer you get?
Positive.
You get a positive. Okay, so there's our first sign pattern. Let's do the next one. Pick a number smaller than -5. Plug it in for x that you would get. James?
Positive.
All right, let's pick a number smaller. Let's pick like -10. If you plug -10 in and you add 5 to it, what kind of number do you get?
Oh, sorry, negative.
Yeah, you get a negative. And now pick a number bigger than -5. 0. Yeah,
Positive.
you get a positive. Okay, so there's the sign patterns for each factor. Now the last step is to take the sign patterns that we created for each, that should say factor, and we're going to combine them together onto one big number line. Well, not huge number line, but one number line. And combining them together, we can look at products and we can look at quotients. There's actually no difference between the two, because what this is going to really come down to is, are you multiplying with a positive times a positive times a negative, or a negative times a negative? And the rule is the same for division. Negative times negative is the same as negative divided by negative. So there's no difference in how you do a product versus a quotient. Okay, so let's combine them together and see what we get. So to do that, you're going to put one number line now, put 2 marks on it. 1 mark for -5, 1 mark for +1/2. And we're going to figure out what's going on in each of these 3 sections. So the first one we're going to look at is the section that's -5 and under. Okay, below -5. If you're on the top number line, what section would you be in if you are -5 or lower in the top number line? Yep.
Negative.
You'd be in the negatives. So I'm just going to put that up here for a second. So that'd be a negative. And if you were in the bottom number line, what section would you be in if you are -5 or lower? Yeah,
Negative.
it's also a negative. And now what we're doing here is we're multiplying them together, because that's how this problem factors. It's something times something. In this case, a negative times a negative. So if you multiply together 2 numbers in that section, it'll be a negative times a negative, which is a positive. So if you pick any number, -5 or lower, fill it in, you will get a positive result. Okay, let's check between -5 and 1/2. Where would you be on the top number line if you are between -5 and 1/2? Yep,
Negative.
that would be a negative. where would you be on the bottom number line if you're between -5 and 1/2?
Positive.
That would be a positive. And a negative times a positive is a negative. Okay. Now the last section, you're going to look at numbers that are bigger than 1/2 on both number lines. Okay, top number line. Bigger than 1/2. Yeah,
Positive.
positive. Bottom number line, bigger than 1/2. Yep, positive again. And a positive times a positive is a positive. So now we've figured out what's going to happen in every section. This is going to tell us the answer. All we have to do is go back up and see what do they want to know. They want to know where the positive sections are. Okay, the question is, where does it come out bigger than 0? So there are two intervals that would come out to positive results. This one and that one. Let's look at, let's call this interval 1, interval 2. What's the lowest that interval 1 goes? Yeah.
Negative infinity.
Negative infinity. And what's the highest? Yeah.
-5.
-5. Can you reach negative infinity?
No.
Can you reach the -5 in this problem? No, it does not have the equal to. So we need a parenthesis on that. Or, now we describe interval 2. What's the lowest that interval 2 goes? Yeah, 1/2. And what's the highest that interval 2 goes? Yeah, infinity. That is the answer to the question. What numbers could you plug into that quadratic problem and get an answer that's greater than 0? Any number in that interval or that interval. If they wanted to know the opposite, when is that less than 0? Well, the answer would be between -5 and 1/2. That's the only numbers you could plug in and it would come out less than 0. And that's how you solve pretty much every problem like this. Any question on that? All right, let's try another one. This time, it's already been factored for you. We don't, this is a cubic. If this was all foiled out, we might not know how to factor a cubic yet. So it's already factored. So first step, make a number line for each factor. And mark all the zeros. All right, we'll start with the first factor. What number would you plug into the first factor to make it 0? Yeah, 0. What number would you plug into the second factor to make it 0? Yep, -3. And the third factor? Yep, 1. I don't know why it does that. Right, now check out the behavior in each section. It's going to be pretty standard. You don't have any negatives in front of these x's, so it's pretty much negative on the left, positive on the right each time. Is there any question how I would be getting the negative on the left and the positive on the right? You do want to check that, because if I did something like this, that would switch it all. Now the negatives would be on the right, and positives would be on the left, because the negative reverses it all. Right. Without that, that's negative, positive, negative, positive, negative, positive. Now we want to put it all together on one number line. We're going to mark all 3 of those on one number line. If you put 3 divisions on a line, how many sections does that break it up into? 4 sections. Yep. So we're going to have 4 sections to check out. The spacing does not have to be like proportional. Just 3 equally spaced marks is what I do. All right, So we got -3, that's the lowest, then 0, then 1. So let's start with the below -3 section, okay, in all of them. In the top number, if I am below -3, what section am I in? Alex? Negative. How about in the middle number line? If I'm below -3, what section am I in? Negative again. And in the bottom number line, if I am below -3, what section am I in? Negative. So if you pick a number that's below -3 and you fill it in, you're going to end up with a negative times a negative times a negative, which is a negative. Yeah, negative. Okay, let's try one more, and then I think you'll kind of see the pattern here. Between -3 and 0. Okay. What if I am between -3 and 0 in the top? What is it? That's a negative. What if I'm between -3 and 0 in the middle? That's a positive. And what if I'm between -3 and 0 in the bottom? That's a negative. And now the answer is the product. Negative, positive, negative. What does that give you?
Positive.
Positive. Okay. The pattern that always happens is it always alternates one to the other. So if you start negative, it's going to be negative, positive, negative, positive. If you start positive, positive, negative, positive, negative. That's how it always works. So you can check the last two sections, but they will come out the same. All right, so now the answer is either going to be the two negatives or the two positives. Let's go back up. What do they want to know in this one? They want to know where the answer comes out negative or positive. Positive. Where is the answer greater than or equal to 0? So that's this section and that one. This is a bounded section. That's an unbounded section. Okay. How would we write the interval for the bounded section, keeping in mind we've got the equal to there? Yeah? Yeah. Yep. So that describes the first interval. That's bounded, closed interval. How would you describe the next interval where it's positive? Someone else describe that one. Esther?
Bracket 1, comma, infinity, parentheses.
Yep, perfect. And those are the numbers that you can fill in to this problem, and it will come out to a positive. Any question on that? Now, if it was let me go back to the first one we did. Let's say instead of being the product of these two, let's say I gave you this. 2x minus 1 divided by x plus 5 is greater than 0. Your top linear, the numerator is the factor 2x minus 1. So you make a number line for that. The denominator is the factor x plus 5. So you make a number line for that. It's exactly the same. Then, when you combine the two together, instead of saying like it's a negative in the first section, a negative in the second one, and you're multiplying them, you're dividing them, but it's still the same answer. So this problem would actually have exactly the same answer as this problem. There's no difference in the answer at all. The only thing you have to be careful about when you divide is that you don't do what?
Divide by 0.
Yeah, you don't divide by 0. So if you had an interval that said, well, it has the equal to symbol, so I can always put brackets. You can, as long as you don't ever have a bracket on a 5 or a negative 5. Because if you put a bracket on a negative 5, you might think, well, it says I could equal it, but then you would be dividing by 0 if you equaled it. So you can't put a bracket on a number in an interval that would cause you to divide by 0. Even if there's an equal sign like that, you still can't put a bracket on it. If it's any other number except the -5, then definitely put a bracket on it. Any question? Now, if you can't solve it with a sign pattern, then we're going to use the calculator. So this is one that's, even if you put everything on one side and get it equal to 0, it's going to be a cubic. It doesn't come out nice. You can't factor it. So this is going to be like put the left in y1, put the right in y2. And we'll use the graph. Okay, so we've got x cubed minus 2x squared minus 5x plus 7. So we're going to call that the blue graph, and that'll be in y1, or whatever color you use. And then 2x plus 1, that's going to be the red graph. So the question is going to be, where is the cubic above the linear function? The cubic is on the left, the linear is on the right. So the cubic is going to be the thing that curves, and the linear one is going to be the straight line. Let's do zoom 6. And in blue, there's the cubic. That's fine. And in red is going to be the line. Okay. We want to know where the cubic is above the line. Okay, it goes above it a little bit, then it goes below it. Okay, so first, actually, let me go like this. There you go. So there's really 4 sections, okay, on the blue line. If I make them different colors, right? That's section 1. That's below the line. Let's call this section 2. That's above the line. Section 3. That's below the line. And then section 4. That's above the line. And the question here is, where are we above or equal to the line? So which 2 sections are we above the line? Yeah?
2 and 4.
Yeah, 2 and 4. Yep. So to describe those intervals, what do you think I need to find on the calculator here? Yep. I need all these intersects. No matter what interval, if you wanted to describe 1 and 3, you'd still need those intersects. I'm gonna start working on the left. If other people could work on the middle or the right and find those 2, that would be helpful. So the one on the left is negative 2.26. And it's going to go up to that intersection that's right in the middle of the screen. Does anyone have that one? Yeah?
0.756.
So 0.76. Okay, now I need to look brackets or parentheses. Well, this isn't a fraction, so I don't need to worry about ever dividing by 0. But look at this symbol. Bracket or parentheses? Yep. Brackets. Or, I described interval 2. That was a bounded closed interval. Now we're going to describe interval 4, which is going to be an unbounded interval. What's the lowest value in interval 4? We have that? Yep. 3 point what?
3.51.
3.51. Bracket is fine because you can include it. And what's the highest value you could go to in interval 4?
Infinity.
Yeah, it's going to be infinity because it's unbounded. Into a 4 just keeps going up and to the right. Now, it had the equal to symbol, so can I put a parenthesis on infinity? No, same thing why I can't put it on it if it was a divide by 0. You cannot reach infinity. And that's your answer. If you wanted to know the opposite of that, then you describe intervals 1 and 3 instead of 2 and 4. And generally, the intervals you describe are not right next to each other. It's either the 1 and the 3 or the 2 and the 4. Any question on that? All right. So then the last 30 minutes, we'll see what we get done on this. This section I think is a little easier than the last section. Not the last section wasn't really hard, but I think this is easier. And in this thing, we're talking about polynomials. Okay, let me give you some examples. 3x cubed minus 8x squared plus 6x plus 2. That's a polynomial. Specifically, that's cubic. If you don't know that name, I'm going to mention it in a minute. I'll write it down. Y equals 4x squared minus 7. That's a quadratic. Okay, that's a polynomial. Y equals 8x minus 4. That's linear. That's a polynomial. The key with polynomials is that the exponent has to be a non-negative integer. 2s, 3s, 1s, those are all fine. But you cannot have any decimals. You can't have 0. Well, you could have 0, I guess, but we just call that a constant. But you can't have negatives and you can't have decimals. That's really important. So the exponent is a non-negative integer. Now, that highest exponent, it has a special name. So like in this case, it would be a 2. In this case, it would be a 1. In that case, it would be a 3. Does anybody know what we call that number? It's the, begins with a D of the polynomial. It's the degree, yeah. So the highest exponent in a polynomial, I'll write it this way. So the highest exponent in a polynomial is the degree. So the highest exponent in a polynomial is the degree of the polynomial. Now, you can't do something kind of cheap like this and say 8x cubed plus 0x to the 5th minus 12. That doesn't really count. So in that case, what would be the degree of that polynomial? Oops. Yeah, it would be 3. You can't really say it's 5 because if you have 0 times something, you might as well just simplify that because 0 times anything just disappears. So the exponent of 5 isn't even really there. Okay. So as long as the coefficient in front of the variable is not a 0, get rid of those. Whatever's left, the highest exponent is the degree. Now, what do you call something that has a degree of 1? It's like y equals mx plus b. What kind of polynomial is that? Yeah?
Linear.
That's linear. Now, if you go up to degree 2, like y equals x squared plus 6, that's a quadratic. And if you go up to degree 3, that's cubic. And now if you go to degree 4, does anyone know that one? Yep.
Is it quartic?
Yep, it's quartic. I don't think we have any names higher than that. We just say it's a polynomial of degree 7, degree 12. But those are the big ones. I can write down 4 if you want. Quartic. For solving all of those, there are formulas. There's a quadratic formula, there's a cubic formula, and there is a quartic formula. Generally, the highest formula you learn in high school is quartic. I've never even learned the other two. So. Okay, easiest thing you can ask about polynomials is what's the domain? The domain is always all real numbers. Never changes. That's because the two things that you're not allowed to do when you're finding domain never happen in polynomials. You can't divide by 0, and you never have variables in the bottom of a fraction with polynomials. You also can't take the square root of a negative. Well, there's no square roots of variables in polynomials. So the only two things that can mess up the domain are never in the problem. So domain is all real numbers. The range, well, it depends. Because think of like a parabola. That parabola has a different range than that one. So you still kind of have to graph it to find the range. It's just kind of the general look of a cubic. We've looked at these. We just did one actually in the last section. A cubic has a highest exponent of 3, which means it can turn twice. Up to twice. It's not a guarantee it turns twice, but it's a maximum on the number of times it could turn. Now, how about a 4th degree polynomial? The highest exponent would be a 4. So how many times could the graph turn at most? Bruce?
3?
Yeah, it could turn 3 times and give you kind of like a W shape. That's a turn, that's a turn, that's a turn. 3 turns. And it's not a guarantee it turns 3 times, it's just a maximum. There are some 4th degree polynomials like this one. If you graph it, it actually looks like a parabola. It's just the bottom of it is flat. It would look more like this. Right, but that's just kind of getting at the idea, if you know the degree and you subtract 1 from it, that's how many times it can turn. Or another way to think about it is the degree is exactly how many times it could cross the x-axis. So 4th degree could cross up to 4 times if the w was in the right spot. It could be 3, could be 2, could be 1, could be none. You get them all, depending on where you put the w shape. Okay, so let's try finding the domain and range of this. Okay. Well, that's a polynomial. I'll just set it equal to f of x. What's the domain? All real numbers. There's no square roots in that problem, and there's no fractions with variables in the bottom. So the two things that would mess you up for the domain are not in this question. So all real numbers. Now, we can be a little bit more specific about the range. When the degree is an even number, you got to check it out. When it's an odd number, you don't. Because odd polynomials go up and down forever. So if it's an odd polynomial, then the range will also be all real numbers. Think of a cubic. It goes up and it goes down forever. But this is not an odd degree. It is even. So it's going to have kind of a parabola shape or a W shape. It's going to have a minimum. And it'll go up from there. Let's graph it. So yeah, x to the 4th plus 2x squared. Oops. minus 8x plus 1. And I remember when we graphed it, we had to set the y-min a little bit lower than the standard window.
So here,
Yeah.
you forgot the plus 5x.
Oh, I forgot the plus 5x cubed. Thanks. 5x cubed. Let's see, how are we looking now? Ax to the fourth is 5x cubed. Okay. So you can start with the standard window, but I'm going to adjust it right away. I'm going to make the y-min. I think let's try negative 15. Now, you wouldn't know that before you graph it, but you'd know it right away after you do. Okay, so it's got the behavior of kind of like a parabola. Right? It comes down, and it basically goes up on each side. How would I find the lowest that it goes? Using the calculator. Remember, yeah?
Second calc minimum.
Yep, second calc minimum. And you pick a point to the left, to the right, and then the guess, well, it doesn't really matter. Remember, range is the y. So the lowest that this graph goes is negative 11.95, and it will reach that. So you can put a bracket on it. What's the highest that it goes? Yeah. Infinity, does it reach it? Any question on finding the range of that polynomial? Yeah.
When we do range, is it always going to be the y value that we put down?
Yes, because domain is the x, range is the y. Yeah. And it might not look like this graph is going forever left and right, but it is. The sides are going to keep expanding out forever, slowly, but they do. So all these different points right here, like this one, and this one, those have a special name. Okay, they're a point where the graph turns. And they're what we call local extrema, okay, local minimums or local maximums. Okay, when I call this a local maximum, local means it's not necessarily the highest y value ever, but it is the highest y value in that area. Okay. This has no highest y value because of this part right here. The highest y value is infinity. But this is a maximum that's higher than everything around it, and this minimum is lower than everything around it. I'm not saying it is the lowest value ever. It's just the lowest value in that area. Okay. So if you want to write that, you can. I mean, it's kind of a pretty straightforward concept, but it's a maximum is a point on a graph that is higher than everything around it, and a minimum is a point on a graph that is lower than everything around it. Now, sometimes you have a point that is the lowest point, like period, like that. That's not only a local minimum, we also call that a global minimum. Global means it is the lowest ever. It does not go any lower at all. So it is a local minimum, but most of the time we call that a global minimum. So local maximum, it's higher than everything around it. Local minimum, lower than everything around it. And together, that you might not know, but I think I said it. Local maximum and local minimum are called local extrema. So if you get a question that says, find the local extrema of the graph, that's what actually we just did in number, whatever it was, the one where we just found the range. that was one of the local minimums, that W shape. It has another local minimum over on the right, and then a local maximum in the middle. So finding local extrema would be finding all of them. All right, so here's an example. X cubed minus 4x. X cubed minus 4x. It says find the local minimum and where it occurs. Now, just to be clear what that means. The minimum itself is the y value. The minimum or the maximum is how high or low it occurs. Where it occurs, that's the x value. So the minimum is what the value is, high or low, that's the y. Where it occurs is the x value. That's important. Okay, so let's find the local minimum. So second calc minimum. We go left, we go right, we do a guess. Okay, so based on what I just explained, what is the local minimum? In other words, how low does the graph go in that area that I just calculated the minimum? Yep.
Negative 3.08.
So the local minimum is negative 3.08. And this occurs when x is 1.15. So 1.15 is the number you would plug into the formula to get negative 3.08. So there's our local minimum and when it occurs. I think the local maximum, it's actually symmetrical. That's not always true, but I think it ends up being negative 1.16, positive 3.08. It's like a reflection. Is there any question on how you calculate a maximum? All right, so what happens? No. So then, if this is a minimum and this is a maximum, what's happening on the graph between A and B? What's my graph doing between point A and B? Yeah, it's decreasing. What's happening on my graph? Let me write that down. So it's decreasing between A and B. Is there anywhere else that this graph is decreasing? Yeah? C to D. And what's happening from B to C? Yeah? It's increasing. So sometimes it's going down, has a negative slope. Sometimes it's going up. That's a positive slope. Does everyone agree that's a local min? So what happens at a local minimum then in terms of increasing and decreasing? Yeah?
It's always going to increase after the local minimum.
What about before it?
Oh, before it? It's going to be decreasing.
It's decreasing. So anytime you want to get kind of fancy, you could say anytime you go from a negative slope and you switch to a positive slope, you're going to have a local minimum at that point. So where is the function increasing? We already did that, B to C. Where is it decreasing? We did that. What happens as you go from increasing to decreasing? Well, we didn't really answer that. That's the other one. What happens as you go from increasing to decreasing? As you go from a positive slope and then switch to a negative slope. What do you get?
The local max.
Yeah, you get a local max. So you get local max. And what happens well, we answered this already the other way. As you go from decreasing to increasing, you get a local min. Oops. M. N. Any question on that? So we'll do the last question tomorrow. We were just about done, but we'll save the last one for tomorrow. All right, so that's the homework. The first page, that's on the sign patterns, and then the second page is on solving the looking at domain and range of polynomials.